You know, almost every single thing you use today, whether it's your car or the phone in your hand, was probably built inside a factory. And those factories are run by a true unsung hero of automation. Today, we're going to tell the story of that hero, the Programmable Logic Controller. We're going to see how one little box managed to replace these massive, clunky walls of machinery, and really, how it paved the way for the smart factories we have today. And this quote right here, from the inventor himself, Richard Morley, it just nails the problem perfectly. Can you imagine trying to convince someone that this little mysterious box full of software could do the exact same job as an entire wall of clicking, whirring machines? I mean, it must have sounded like absolute magic. Or maybe just crazy talk.
And this is what he meant by 50 feet of cabinets. Wow. Before the PLC, this was it. This was reality on the factory floor. Every single decision, every machine sequence, every safety check was hardwired into this just dizzying web of physical relays and wires. It was basically a mechanical brain, but man, what a maintenance nightmare.
Okay, so let's really dig into why this system was such a massive headache. You have to understand, in the time before PLCs, control wasn't programmed, it was physically built. And that meant any change, no matter how small, was this huge, inflexible, and seriously time-consuming project.
This list pretty much sums up the daily nightmare for engineers back then. Just picture it. You want to make a small tweak for a new car model. You can't just, update some code. Nope. The entire assembly line had to be shut down. We're talking days, sometimes weeks, while electricians physically rewired hundreds, maybe thousands of connections. All that downtime, insanely expensive. And troubleshooting? It was a nightmare. Just trying to hunt down one single loose wire or a dirty contact point in this giant sea of identical parts.
Yeah, this just couldn't last, right? Especially in the fast-paced world of automotive manufacturing. With car models changing every single year, this whole relay problem was completely unsustainable. Somebody had to come up with a better way, and that call for a solution came straight out of Detroit.
And here it is. This was the moment. In 1968, General Motors basically threw down the gauntlet. They put out a formal challenge to the industry. Build us an electronic solid-state system to replace these relay panels. They needed something flexible, something reliable, and something programmable. This document right here was the starting pistol for the race to invent the PLC.
So the race was on. 4 companies took on GM's challenge. But as it turned out, it was one team, led by a particularly brilliant and unconventional engineer that would not only meet all the requirements, but would actually invent an entirely new category of technology.
And what they came up with was the PLC. At its heart, it's a special-purpose computer. But listen, this was not like the delicate, room-sized computers of the 1960s. The PLC was built tough. It was industrially hardened. It was solid-state, which is just a fancy way of saying it had no moving parts, unlike a clicking relay, which made it way more reliable. It was designed to survive out on the factory floor, to handle the heat, the dust, the vibrations, and just do one job with perfect reliability: control machines.
And these are the guys who pulled it off. That's Richard Morley on the far left with his team from a company called Bedford Associates. And their invention was called the Modicon 084. Why 084? Well, because it was their 84th project. This box was their answer to GM, and it would go down in history as the first commercially successful PLC ever.
But the hardware, as cool as it was really only half the story. The absolute genius of the Modicon 084 was its software. See, Morley and his team knew that for this thing to catch on, it had to be easy for people to use. So instead of some complex computer code, they invented a brand new graphical language called ladder logic. And this is why it was so revolutionary. I mean, look at it. That doesn't look like computer code, does it? It looks almost exactly like the electrical schematics that technicians and electricians were already using every day. The vertical lines are the power rails, and the horizontal rungs hold the logic. This was brilliant because it meant an electrician could look at a PLC program and understand it almost instantly. It just completely lowered the barrier to entry.
So how does a PLC actually think with that logic? Well, it follows this super simple but relentless loop called the scan cycle. It's a 3-step dance. First, it checks all its inputs, all its senses like buttons or sensors. Second, it executes that ladder logic program you wrote, one rung at a time. And third, it updates all the outputs, its muscles, things like motors, lights, and valves. And it does this entire loop over and over, thousands of times a second.
Simple, fast, and unbelievably reliable.
Okay, so that first Modicon 084 was a total game changer, no question. But it was just the beginning. The PLC did not stay a baby for long. Over the next 6 decades, it evolved from just a simple relay replacer into the powerful brain of the entire modern factory.
This timeline really shows you just how fast the technology took off. You can see the two early giants, Modicon and Allen Bradley, constantly trying to one-up each other. Look at Modbus, for example. Modicon introduced that in 1979. It was the first industrial network that actually let PLCs talk to each other and to computers. That's a feature that is totally standard today, but it was revolutionary back then.
If we break it down by decade, you can see this clear path forward. The 80s were all about standardization and getting these things to talk to personal computers. The 90s, everything got smaller, faster, and we got the speed of Ethernet. Then in the 2000s, as factories got more and more connected, security suddenly became a huge deal. And of course, in the 2010s, PLCs moved to the cloud, becoming a key part of the Internet of Things and this whole new wave of smart manufacturing called Industry 4.0.
And hey, we've got to give a shout out to another major player. While Richard Morley is rightly called the father of the PLC, he wasn't the only one in the game. Odo Josef Struger, an engineer at the rival company Allen Bradley, was another key pioneer. He was crucial to his company's success, and is actually the person credited with coming up with the acronym PLC, Programmable Logic Controller, the name we all still use today.
All right, so that brings us to today and tomorrow. And believe me, the story is far from over. In fact, things are getting really interesting as the lines are blurring between the classic PLC and its even more powerful cousins, leading to this explosion of new capabilities. Nowadays, you'll often hear people talk about PACs, or Programmable Automation Controllers. Here's an easy way to think about it. If a PLC is a specialist, totally laser-focused on controlling one machine really fast, a PAC is more like a general manager. It's using more advanced programming languages and can connect to databases to oversee an entire system. But honestly, today's PLCs are getting so powerful that that distinction is getting fuzzier all the time. So what does the cutting edge, the 6th generation of controllers look like? Well, we're not just talking about controllers anymore. These things are genuinely smart. They're running AI models to predict when a machine is about to fail. They're using something called edge computing to process data right there on the factory floor, instead of sending it all to the cloud. And of course, they have incredibly robust cybersecurity built right in to protect our factories.
When you step back, it's just an incredible journey, isn't it? From a simple box designed to save electricians from having to rewire panels to an intelligent, globally connected device that's running artificial intelligence, the PLC's evolution is really a mirror of our own digital transformation over the last 50+ years. It really makes you wonder, what on earth will the factory of the future, run by the controllers of tomorrow, even be capable of?